Yeah, now let's consider the topologies. So, what do you think a topology is? A network topology. Yeah. Yeah. Any you're saying the types of topology. Do you have any idea of topology, the definition of topology? It's okay. See, topology is very simple. Topology is the connection of the physical devices. Now, whatever you told, the bus, star, mesh, all these are all these tell how the devices are connected physically. Yeah. This is how the devices are connected. Topology is very simple. The plan or the architecture, how the devices are connected. Okay. Here we have a example, a small sample of topology. Okay. Actually, the topologies are of two types mainly. That is one logical and the physical topology. If you're considering the logical topology, that is what the network looks like to the end device, or else you can say that how the message or packet flows. Okay, wait, let me tell you in this way. My switch, this is my router, and one more router, router, and these all three in turn are connected to one more router, and it's my switch. Okay, and this PC wants to communicate with this PC. Okay, actually, this is my topology. This is my physical topology. Physical topology is physically how the devices are connected. That is my physical topology. Then what is the logical topology? Logical topology is now I am sending a message. I am sending a message hi from this PC to this PC. Okay, the message has gone through the switch to this router, and from this router to out of all these three routers, only one will be selected. Right? Only it can go. The message can go through only one way. For suppose think that it has gone through the middle router, and from this router to this router to switch, and switch to PC. Now my logical topology is 1, 2, 3, 4, 5. Okay, now my logical topology will be PC, switch, R1, R3, R5, and then switch, and then PC. This is my logical topology. But my physical topology is actually consisting of two PCs, two switches, and 5 routers. But for my logical topology, all these devices are not used. My logical topology is how my message goes, how my packet flows. That is logical topology. Okay. In real time scenario, actually you will have redundancies. Okay. They have a pre-plan that if this device goes down, immediately there must be another device to respond. Okay. At that time, you will have this topology. For redundancy purpose, I used 1, 2, 3 routers. Okay. What if my this path goes down? then immediately the packet has to switch to another route, right? Then at that time my logical topology will be from R1 to R2 and R2 to R5. And if this also goes, R1 to R4 and R4 to R5. Logical topology. So you got the physical topology and logical topology, right? Done. Yeah. So logical topology, physical topology, and yeah, see physical topology, how the network is actually cabled. Okay, so we have some predefined physical topologies like bus, star, ring. I think you know already this bus, ring, star, all. And you also have fully meshed and partially mixed. Okay, yeah. Now up to now, whatever we discussed, the physical components, topologies, cables, devices, if we keep all them together by applying the logical logic and all these components, the output will be our network. Okay, and yeah, I told you already the Cisco three-layer hierarchical design. The first layer will be the access layer. Yeah, access layer. Now you have distribution layer. As I told you already, if the communication between two access layer devices must happen, ultimately the data has to pass through the distribution. Okay, and after this you will be having the core layer. In order to make one branch may communicate with other branch, we use core layer, where the core devices will be interconnected to ISPs through which the communication will be possible. And what is this? This is the latest design suggested by the Cisco, that is collapsed Cisco core, collapsed core layer. What actually happens here is the access layer remains the same, but the distribution layer, whichever was present in the older hierarchical design, now the core layer and the distribution layer both are clubbed together, and this will be the collapsed core layer. Okay, in the older phenomenon, if the access layer device needs to communicate with the access layer device, ultimately the data has to pass through the distribution layer. Yes, but in collapsed core layer, the data directly goes to the core layer and again comes back. Yeah. Okay. More faster? It is not regarding the faster. It is all dependent on the, see, basically if you are a network associate, now a company has given you, always company will give you some budget, some x crores of some x millions of dollars or something is given to you, and they have some requirements that this must be my requirement. Okay, now the design, whatever you design and your implementation will be dependent on these two. Depending on these two, you need to make an equation, and based on that equation you should design the thing. Okay, the previously shown core three-layer architecture and this one collapsed core design, there's no difference between them. The only thing is it all depends on the budget. Okay, it is not about the faster, it's always about the performance. Okay, in three-layer hierarchical design you have two more devices extra, where the burden of the core layer devices will be low. But here in the collapsed core layer, the burden or the pressure on the core layers will be high, because it has to perform the responsibilities of the distribution layer and also as well as the core layer. It will be useful. That's what I'm saying. It depends on the budget and the equation what you have, and according to that you divide it. Which one will be the more cost? Ultimately, the older, because you are having the more devices, but here you will be having only one core layer device, and devices are low. Ultimately, the cost will